Thank you, thank you. Good morning. Let's see, what are we going to talk about today? First, who am I? Well, I've been in ClueCon a couple of times already, so maybe you already know me. People refer to me as Zoa. I'm one of the founders of Zuiper, and I'm currently employed as a plumber at Vanheuverzwijn. I make the pipelines for the machine learning training, or at least I try to help a bit with it. I'm also severely jet lagged today, so if I suddenly black out, stand here for a bit, just give me a sleeping bag, let me sleep a bit, and I'll be better. So what is Vanheuverzwijn? I'm one of the founders of Vanheuverzwijn as well, and Vanheuverzwijn consists of two parts. The first part is something more end-user oriented, that provides meeting transcripts and all kinds of AI on top of it. And so it offers different ways of making recordings of Google Meet, Jitsi, a Zuiper call, a PBX call, whatever you want, upload it to our website, make transcriptions for it, make summaries for it, extract maybe key action points, things like this. But it's probably not so important for today. So this is how it looks like. So here's a summary, if it doesn't matter. There's a second part to the company where we decided to license out the key building blocks of the technologies we use to make this. And more in particular, it's mostly speech to text. And we made a bunch of both streaming and normal models that we will offer as an API and also as self-hosted models, because we get quite a lot of requests for that in Europe, at least in terms of privacy. Our aim is to make it possible, to make it cost affordable, to make transcripts of absolutely every conversation you have. So to do that, we have to be rather cheap, right? Otherwise, it's always expensive. So the parts we built, the parts we will license out, is either an API that's probably going to be like 10 cents an hour instead of $1.40 with Google, I think. Or we'll offer you a self-hosted WebSocket server for a reasonable price per month to transcribe everything you want on your own hardware. We also have a bunch of SDKs for mobile and for probably in the future for the browser. I'll give a demo later. If you want to play with it while I'm talking, you can try to see how it picks up on my accent if you take a screenshot for it. While I talk about the next thing. This is purely coincidental, this whole Marty stuff, what to do. So this is a bit what we want to do in the future. If we have the live streaming, we can do all kinds of analysis on the live. I wanted to give a demonstration more about this stuff today, but I didn't manage to do it on time. So what is today's presentation about? I'll start by going back in time. In 2021, I think, I spoke about how to train your own speech-to-text models. Last year, I spoke about cloning the voice of Trump and Allison. And let's update a bit what has happened since on the market of speech-to-text and text-to-speech. So in the last 2 years, there hasn't been all that many new developments. It's more of an evolution of what was already there. There's more variations on transformer. So back then there was, I think, transformer, conformer. Now we have branch former, squeeze former, zip former, and a bunch more paraformer. But the scores, the error rates go down a bit. They get a bit faster. But I think nowadays all the toolkits somewhat offer the same type of models, and you have similar results with them. One big thing that is happening is that people move away from CTC to transducers, mostly to be able to run on endpoints, but we won't go too much into detail. The other big part that has changed in the last year, mostly actually, is that there is a focus of some of the big companies to out-compete each other on multilingual models. It started with MCTCT, then there was Whisper, Facebook MMS, and then there's some paper on Google USM. So MCTCT was made by Facebook, I think 2 years ago. It's not very well known, but it's a cool paper to read how they did it. So they started by labeling, by making training on a data set with a lot of audio that they had labels for. And then they threw in some smaller ones, some smaller languages that they didn't have a lot of labels for, low resource languages. And they did fine-tuning on every one of those languages individually. And then they took all these pseudo-labels and trained on all of them in a big batch. And they were able to train the models again then, and then they had better results on small ones. So this is about 60 languages. And I think it was the first one before Whisper came out. So Whisper is trained on 680 hours of inaccurate transcripts that they just downloaded from the internet, scraped. It comes with quite crappy language detection. And it has a few issues, but it's actually, for English, it's really good. It's not very fast, and it doesn't work all that well for other languages. Like the more resources, the more data they had for the language, the better the language is going to be. In our case, we obviously tried to beat Whisper. So we eventually managed. It took us an awful lot of time. And for English, it was quite hard. For other languages like German or Spanish, it was relatively easy to do so. When I say it has crappy language detection, when you read the white paper, you can see that the labels they downloaded, they first needed a language detection to determine that this was the language that matched with the transcript. And they trained it on a very small data set, and I think that's what's causing most of the issues with the Whisper model related to translation issues. And to give you an example, with me in the company, I work in Bulgaria. So I have meetings with Bulgarian people, but we speak English. But when we transcribe the meeting with Whisper, for some reason, it's always translated into Bulgarian. And since Bulgarian is an extreme low resource, for ASR at least, language, it's really miserable Bulgarian. It's mostly made up words. But it is free. You can speed it up quite a lot on CPU. It's still not all that great. And for English, it's quite good. And it supports like 100 languages, but I think more than a handful, or okay, the rest is not so good. So the next one is Meta MMS. Not very well known. I don't know why. It's a cool way how they trained it. So they thought, okay, where can we find the most low resource languages? And they found a website that offers recordings of Bible readings, New Testament. And it had 55,000 hours of people reading the Bible, some of which just 2 hours in some weird language. So they made a big pipeline to process and to align those things. And they had an interesting way to train the data, because obviously they had nothing to compare with for some of these languages, because nobody has bothered to make speech recognition for some of these languages. So they split this data set in two, train the model on the first half, and then use that first model to check the audio for the second half, that the transcripts actually matched or seemed to be close to what they had to be, and it was not just complete rubbish, and then they switched the sides. It is probably a bit more complicated and a bit smarter than the way Whisper was done, but it has a lot less audio. And although they claim that the quality is better than Whisper, it is only true for the low resource languages. And so on average, they might be better, but I would be very surprised if they beat Whisper on conversational audio, because in the end, it's still people reading the book, always the same book. So it's probably really good at doing transcriptions for the Bible. They also have language detection, and the language detection there is made in a much better way. So if you ever need language detection, look at this one, don't look at Whisper. You're not allowed to use this thing for non-commercial purposes, though. And I don't know exactly how many languages it is. I don't know if it's 1,000 or 8,000, but there's a lot of them. But again, the quality for the low resource languages, it is better than Whisper, but it's still easy to do it, or relatively easy, for another company like ours to beat them on this, just by doing training specifically for one single language. So what I really wanted to present today is how to self-host some of these models. First I have to talk about the text-to-speech. So text-to-speech in the last year actually is a much bigger improvement, than a much bigger change than what happened to the speech-to-text. It got the generative treatment. So whereas when I gave the presentation last year, there was only Tortoise TTS that was doing the real generation based on long context transformers. a lot more papers came out, white papers came out from the big companies on how they do it internally. And we'll see it in the next slide. But the big difference is that this sounds much more natural. And you can give it some hints on how to do the thing. It's similar to how you can generate an image and you say, I want to have a frog riding a donkey with a background of something like this. You can do the same thing now with audio. These are some of the models. So the MMS TTS, this is just something related to the Meta MMS. There is text-to-speech in it for over 100 languages. It's not good, though. It's not good. It's really not good. Then you have Tortoise TTS, which is the same as I spoke about last year. They have some speed optimizations, but other than that, nothing new. And then you have, I think it's Microsoft that has Valley. There's Bark, there's Natural Speech 2, and there's Meta Voicebox. Most of those were only white papers, but you can find some half-finished reference implementations, or not reference implementations, half-finished people trying to reproduce things from the paper with maybe some shortcuts here and there. And especially the Meta Voicebox is interesting. They didn't release any code, just a paper. But it allows you to not just create audio, but you can modify audio. So you can ask it, oh, make this person sound more happy. Or remove the ambulance that is driving in the background on this audio clip. So, where I really wanted to be. Oh, and I even got it through airport security. So, who's using speech-to-text in production? Okay, anybody else? Okay, some more people. What do you use to do so? Do you use the cloud? Do you use like Google, Azure? Hosted? Hosted somewhere in the cloud? On-premise hosted, okay. Okay. Are you using Vosk or Whisper? Something Hugging Face? Ah, okay, you're paying for something something on-premise, okay. So, why would you self-host it? Maybe I can ask you a question. I can reward you with the beautiful banana. Yes. Okay, so the answer is, in brief, that it's a latency situation there. And I can somewhat attest to it, because I tried to give a demo of a streaming model in the hallway earlier, and it didn't work all that well. And when I try it in the office, it always works really well. So I think that for streaming models, you don't want to have any jitter there. It needs to be, if you have low latency and you have no buffering, then obviously you will have an issue there. But so most of the people seem to have an issue that the cloud is too expensive. This is the reason why we started our models and we started training them ourselves. We couldn't afford $1.40 an hour to do a €10 per month subscription. It just wouldn't work. The low latency is something that's most important for like telecom operators. They really want to have it close by. If you want to make these voice bot demonstrations like we saw yesterday, you don't want to have another second of delay in it, or have something misrecognized because you had some jitter in there. This is something that really annoys me. I use a lot of ChatGPT, and I find very annoying that when they do an update, this prompt no longer works. And you have to make it a little bit different. Now, I don't think for speech-to-text that they change these things all the time, but they might still have an outage somewhere which causes problems for you. Something that's quite big in Europe is that they don't trust the US. They're afraid of the privacy implications, that somebody is going to steal the intellectual property and that somebody else might be listening in on Google Cloud, for example. Or there might be other requirements where they are not allowed to send it to the US. I think something changed recently in the regulations for this, but until recently this was the issue. But some people maybe just want some specific model for a specific domain. I don't know, some medical thing, some financial, well, it could be anything. Or maybe you just want to make a model because you can. So where to get the models from? So you could license them from us. You could license them from us. You could download free ones from Vosk. There's an awful lot of models on Hugging Face. You have Whisper, and you have Facebook MMS. Or you can look at the presentation from 2 years ago and make them yourself, which is going to take a while. Now, what are the issues with the existing models that you can just download? Most of them, with the exception of Whisper, are not really used for anything outside of R&D. So the models are trained to get the highest score on specific data sets, or they are trained to have fantastic results, but the frameworks there are not made to give you something that you can run in production. And there's actually quite a lot of things to do to make this run in production. So we'll go a bit through this list. So, for starters, if you go to Hugging Face, all these models are going to give you some PyTorch code, some PyTorch model. And you could run this, yes, if you want to just decode 1 or 2 files, it's going to be fine. But if you want to deploy this, I don't know, in a customer premise or in your own servers, or on a mobile phone, you first have to install Linux. You have to have PyTorch on top, then NumPy, then Torch Audio, Python. God knows what else. You'll end up with gigabytes of things, and you're not going to be able to do this on iOS. An iPhone is not going to like this. When you have these Docker things, something we see a lot, so we obviously have some production at PyTorch also. Sometimes one of these packages just changes, and then you end up in this huge dependency hell and spend days fixing it just because one package updated and all the rest can't follow. There's bigger issues with PyTorch as well. If you want to run this from a free switch setup, then you probably want to be able to support like more than one concurrent call. Probably want to do a bit more. If you want to do hundreds with Python, probably not going to be the best idea. So there's some solutions for it. There's some portable formats, some intermediate formats, ONNX, NCNN, and a bunch more that you can export to, which make it independent from PyTorch. And all you need is a small runtime to run this. And the runtime is a couple megabytes. So this suddenly makes it possible to run your model with very little excess code on iPhone, on Android, in the browser. Or just on a server, like the one we made. But it's not good enough. Just this model is not going to help you, because the code around the model, to do the post and the pre-processing, is kind of important as well, because you don't start with the raw audio. You start with an audio file that you cut in pieces, typically less than 30 seconds, because anything over 30 seconds will make the model go really slow. Then you convert it to an image file, a MEL spectrogram. Then you kind of decode all the little pieces, then you reassemble them. You have to watch out, because when you cut it, you probably cut the word in half somewhere. So this word is going to be wrong at the beginning, at the end of the first sample, and wrong at the beginning of the second one. So you have to do all kinds of trickery there. And at the end, you have to convert whatever tokens you got out back into words. For text-to-speech is something similar, because you need to normalize your audio first. 5 to 5, Mr. to Mr. The problem is all the code that you find to deal with natural language processing is going to be in Python. All this stuff, mostly going to be in Python. So you have to re-implement all of that for the platform you want to use. So you have to do it in C++, you have to do it in Java. It's not going to be Python anymore. So there's quite a lot of work to do there. For large language models, or for the specific use case, there's another thing, but not it. So what about running this from FreeSwitch? Let's say you have a model, and you have some basic setup to do this. What use cases do you have in FreeSwitch? So there's 3 big ones. There's one where you can do everything with a long delay in between. Voicemail, it's not really critical to be within 1 second. So you have 30 seconds or so. So you could just have a batch script that looks for new files, processes them, sends a transcript somewhere, does it like this. This is the easiest way. And this is something you can do with the research models. Because you can just loop to it, different languages, doesn't matter, it's going to be fast enough probably, because who uses voicemail now anyway, right? For the transcript, for normal calls, it's going to be a bit different. But the second part is if you want to make maybe the very basic versions of yesterday's demos. with the chatbots, the voice bots. There is some standard for it, which is MRCP, which used to be in FreeSwitch, but I think the model is at least no longer maintained. We made a plugin for this one. We'll release it soon open source, so you can make modifications to use it with your inference server as well. This is how it looks like. So we have a plugin for the UniMRCP, and then this is our self-hosted thing. And then you just go to FreeSwitch and go to the rest. But this will, for every request, so let's say I want to order a burger, for example. It will send this to our server. It will come back, end up as some variable in your dial plan. You can do something with it. But then if you want to do the follow-up question, it is going to open a WebSocket connection again, which is maybe not the most optimal scenario. And you can't really talk and interrupt it like they did on the demo yesterday. So there's a need for a better solution for this, which SignalWire obviously already has, and we'll have to see if we can put something in FreeSwitch as well, where we can actually stream this audio for the third case, to be able to live subtitles or to have a real streaming voice bot experience. So back to this inference server. You need it to scale. FreeSwitch can handle a lot of simultaneous calls. You need to be able to keep up with them. And there's some solutions for that, but first you kind of need to decide what you're going to use. I think Richard gave a presentation yesterday about encoding things on the GPU, Opus. Working with GPUs is not all that easy. There's a lot of challenges involved. And most of them are related to either there's limited memory and you can't do 17 models at once, or with batching. If you want to process a 1-hour file, it's easy, right? You can send it in multiple pieces. Or if you want to do 10,000 files at once, it's OK. You can batch them, get all these cores to work. It's relatively straightforward. But if you want to do streaming calls, then all these calls kind of have context for the previous words that they need for the language model. And still, you need to get all these kernels, all these cores loaded. So that thing is not trivial. One of the most annoying parts is just its hardware. The thing falls off the bus. We have 80 GPUs. I think six of them died in the last 2 years. But falling off the bus is more common, which means you have to stop the server. Very often it doesn't reboot. Somebody has to push the button, or you have to physically turn it off. And you cannot buy them at the moment. NVIDIA stopped producing, let's say, consumer editions with blower cards. You need the blower cards because you need to get the hot air out of the case. And let's say they have another solution to get the hot air out of the case. The normal fans are not very reliable. So if you want to buy one of those cards, I think the cheapest one is maybe an A40 or so, or an A10 that you can use. I don't know exactly what models were, but it's a lot, and it's still months of waiting for them. Or you could opt to do it on the CPU. Like by default, we work with the CPU. We could do GPU as well. On the CPU, things is a lot easier to do parallel. You could easily run 100 models, because your RAM is cheap. You probably already have a lot of excess capacity, either on your existing production servers. Our models that have the same, like for English, have the same quality as Whisper, but we can do 20 times real time on a single CPU core. That means that whatever your PBX can handle, and it's less than 50% CPU usage, we can probably do a transcode every call at the same time on the same hardware. It's still not trivial, though, to do this. So if you want to write the software yourself, it's not that simple. So you need some inference server. So the first one, this is the one we wrote, Vanheuverzwijn. But if you want to do a very serious deployment, probably the most used one is Triton. I don't have all that much experience with it. It's the system administrators working with it. It's something we use for our large-scale deployments. You can put your pre and your post-processing in there since last couple of years, I understood. And this will handle most of the work for you once you set it up, obviously, which is not that easy. But it will do the batching for you. It will do the load balancing, the monitoring, the scaling to multiple servers, multiple models on a single GPU, all of this it will somewhat deal with. And it has a REST, or I think it's a gRPC API in this case, where we have a WebSockets API. It doesn't work for absolutely every model though. And you still have to do other things on top of it, because you can't just expose this to the internet. Everybody will just abuse it. So, well, this was a demo for you to try, if you want to. But I have another one. Let's see. So this is a locally running model, no server connection, everything in the browser. It's just a proof of concept, but this is where the transcript is for the audio file. So it is possible. I have to say that this WebAssembly stuff, it's 3 times slower than doing it just natively on the same thing. But it is a possible solution for call centers who want to go even further, or maybe people doing hosted PBX who have a WebRTC-based solution, where they do not want to have the transcripts on their servers at any time. It can all be done client side. Those models work real-time, 20 times real-time single CPU core. They work fine on iOS, all the recent iOS iPhone versions, and I think most of the Android phones. There's even acceleration for Vulkan for GPUs for them. And I think that's probably it, unless somebody has some questions for me.
That's very kind, Zoa, to offer questions. We do have time for one question, if anyone has a question for Zoa or Joachim, as he's sometimes known as well. Any questions here? We've got a microphone man on hand. James has a question. He's right at the front, just to make the mic running extra exciting. Is that thing on? It is on. It is on.
There we go. Not really a question, just an observation. With Luca at ClueCon, we actually did a demonstration using your banana phone recognition.
Mm-hmm.
We put the speech recognition, actually embedded it into a 5G radio. And the results were absolutely stunning. The low latency was unbelievable. And because we were doing all the recognition at the front end, that was then piped back down the backhaul back into the signal wire AI piece to do the intelligence bits. And the amount of data that we were having to move on the backhaul was tiny.
It's just text, yeah.
Yeah, it's just text. All the hard work was done by Bananafo, working in a very economical way on the front end. So, thank you for doing that. Absolutely brilliant work, Joachim.
Less of a question.
So some of the models might have leaked already in the.
It was more of a testimonial, James, wasn't it?
More of a testimony. I'm saying, just telling everybody, the stuff that Joachim's done is absolutely brilliant. So. Thank you for that.
Okay, big round of applause for Joachim, or Zoa, as he's sometimes known. Thank you. Thank you, sir.